Hello everyone, this is Dr. Mahender, Faculty of Mathematics, B.V. Raj Institute of Technology, Narsapur. Course name is Linear Algebra and Calculus. Today I am going to cover the topic name is Properties of Eigenvalues and Related Problems. So before going to today's class, just I will recall the previous topic what I covered. So mainly I covered the definition of the eigenvalues and eigenvectors, what is the significance of eigenvalues and eigenvectors, and also I covered some of the applications related to the eigenvalues and eigenvectors. Just I'll recall one more time the definition of the eigenvalue and eigenvectors. A non-zero vector x is said to be eigenvector of a matrix A if there exists a lambda such that Ax is equal to lambda x. So this is the mathematical definition of the eigenvalues and eigenvectors. What is the significance of the eigenvalues and eigenvectors? So whenever if you operate matrix on vector, so generally change both its magnitude and direction. But however, matrix may act on certain vectors by changing its only magnitude, leaving the direction unchanged. Such vectors are called eigenvectors. The multiplicity is called eigenvalues. And also we discussed some of the applications related to the eigenvalues and eigenvectors. Just I'll quickly review that whatever discussed in the previous class, the application. One is the principal component analysis and page rank algorithm and design of the bridge in the construction and also the design of the car stereo system. But today's class I am going to discuss about what are the properties of eigenvalues and the problems related to the properties of eigenvalues. So the first property, if lambda is an eigenvalue of matrix A, then lambda is also lambda is also an eigenvalue of its transpose. What is the first property? If you know the lambda is an eigenvalue of a matrix A, the same lambda is also eigenvalue of its transpose. The second one is 1 by lambda, provided lambda not equal to 0, is an eigenvalue of A inverse. So if you know the eigenvalues of A, by using this property, so we can calculate the eigenvalues of its inverse. The next one, the lambda power k is an eigenvalue of A power k. So by using this property, if you know the eigenvalues of A, by this property, so we can calculate eigenvalue of power of a matrix. The next one, lambda plus or minus k. If lambda is an eigenvalue of A, then lambda plus or minus k is an eigenvalues of a matrix A plus or minus ki. If lambda is an eigenvalue of A, then lambda plus or minus k is an eigenvalue of the matrix A plus or minus ki. The next one, then k lambda is an eigenvalue of the matrix K. So once we know the eigenvalues of A, by using these properties, we can find the eigenvalues of inverse, eigenvalues of a power of a matrix, eigenvalue of the scalar multiplication of a matrix we can calculate by using this property. And the next property is very important property. So after obtaining the eigenvalues, whether the obtained eigenvalues are correct or not, by using these properties we can check it. So the property is sum of eigenvalues is always equal to the trace of the matrix. The products of eigenvalues equal to the determinant of the matrix. Suppose if A is a 3 by 3 matrix, so according to the characteristic equation, it has the 3 eigenvalues. Therefore, the sum of eigenvalues, let us write lambda 1 plus lambda 2 plus lambda 3 is equal to the trace of the matrix. What is the trace? The trace is the sum of principal diagonal elements. The product of eigenvalues equal to determinant of the matrix. So these two properties are very important properties. Even after this obtaining the eigenvalues, so before proceeding to the next step, so make sure that the eigenvalues satisfying these two conditions are not. If at all, if fails any one condition, you can recheck so the obtained eigenvalues are correct or not. If you any one condition is not satisfied, so you can redo and again check it. It has to compulsory satisfy these two conditions. Sum is always equal to the trace of the matrix. The product is always equal to the determinant of the matrix. Now we will move to the problems related to the properties of eigenvalues. If A is a square matrix of order 3, 3 minus 1, 1, minus 1, 5, minus 1, 1, minus 1, 3. So A is a 3 by 3 square matrix. The first row is the 3, the minus 1, 1. The second row is the minus 1, 5, minus 1. Third row is the 1, minus 1, 3. Then find the eigenvalues of for the following matrices. The first one, find the eigenvalues of A. The second one, we have to compute eigenvalues of A transpose. Third one, find the eigenvalues of the A inverse. Then fourth one, then compute the eigenvalues of 4A inverse. The fifth one, the eigenvalues of A square. Then sixth one, then compute the eigenvalues of A square minus 2A plus I. The last seventh one is the compute eigenvalues of A cube plus 2I. So the question is, he has given one matrix, 3 by 3 matrix. So once you know the eigenvalues of this matrix A, then by using the properties of eigenvalues, they compute the eigenvalues of the following matrices. The first one is what is the eigenvalues of A, what are the eigenvalues of the A transpose and A inverse and 4A inverse. So all these we can obtain by using the properties of eigenvalues. So before that, we have to find the eigenvalues of a matrix A first. So how to find the eigenvalues of the matrix? By using characteristic equation. So what are the characteristic equation? So characteristic equation is the determinant of A minus lambda I equal to 0. So this equation will give the, depending on the order of the matrix, will give the, suppose if A is the 3 by 3 matrix, this equation will give the third degree equation. Suppose if A is the 4 by 4 matrix, this characteristic equation will give the fourth degree equation. Solving that roots of that equation will determine the eigenvalues. But here we have the shortcut formula also we have for the if A is 3 by 3 matrix. If A is 3 by 3 matrix, the corresponding characteristic equation will get the third degree equation. So we have the shortcut formula is for the 3 by 3 matrix, lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. So instead of proceeding with the general formula, this determinant of A minus lambda is equal to 0, if you proceed with this formula, so we will get directly the required characteristic equation in the proper manner. Okay. So now here what is the S1? So here S1 is the trace of a matrix. What is mean by trace? The sum of principal diagonal element. Just so 3 plus 5 plus 3, so equal to 11. What is the S2 we have in the formula S2? The S2 is the sum of minors of principal diagonal elements. I will write here, sum of minors of principal diagonal elements. So what are the principal diagonal elements? The elements lies on the principal diagonal are called principal diagonal elements. Then how to get the minors of the principal diagonal element? So the minor of A11, the minor of A11 is obtained by deleting the first row and first column. If you delete the first row and first column, we will get the 2 by 2 matrix, that is the determinant of the 2 by 2 matrix, the 5 minus 1 minus 1, 3. So this is the minor of A11. So minor of A22. So the second principal diagonal element is what? A22. Then how to obtain the minor of A22? The deleting the second row and second column. The elements lies in the row and column. If you deleting, will whatever the determinant will get the 2 by 2. That is the minor of that element. Okay. Now the minor of A22 is obtained by deleting the second row and second column. Will get the 3. This one, deleting the second column and second row, 3, 1 and 1, 3. Then the next one, A33, the minor of A33 obtained by deleting third row, third column. So this is third row and third column will get 3 minus 1 minus 1, 5. So all of you familiar then how to compute the determinant of 2 by 2 matrix. Suppose if A is the if 2 by 2 matrix or determinant of how to A, B, C, let us say this one. Then how to compute this determinant of 2 by 2 matrix is AD minus BC. First you have to multiply this two. Okay. Now by using this formula, the 15 minus 1, 9 minus 1, this one, 15 minus 1. So that is equal to what we will get. This is the 14 plus 8 plus 14. Then 14 plus 14, then 28. Then 28 plus 8 will get 36. Now this is what S2 value. S2 is what we computed, the sum of minors of principal diagonal element. Then next we have to compute the S3 is the determinant of the matrix. So all of you well aware how to compute the determinant of the matrix, the sum of products of elements of any row or any column with corresponding cofactors will give the determinant of the matrix. So I am using with respect to the first one I am going to compute. So this 3. Now this one 15, 5, minus 1, minus 1, 3. Then here minus minus here plus. Now deleting this second column and first row. This is what? Minus 1, minus 1, 1, 3. Now this is plus 1. This element into the minor is obtained by this element. Deleting the third column and first row. This is the minus 1, 5, 1 and minus 1, 5, 1 minus 1. Now we can do this one. 3. This is the 15 minus 1 is the 14. This is the 1. This is the minus 3 is plus 1. Minus 3 plus 1. This is 1 minus 5. The 14, then this is the 14 3 is the 42. Then is the minus 2, minus 4. This is what, if you, the 42 minus 6. So 42 minus 6 is again, we'll get the 36, the value of this 36. So now we computed this using this formulas, the S1, S2, S3. The S1 is what? Trace of a matrix, that is sum of principal diagonal element. S2 is the sum of minors of principal diagonal element. The value what we got? 36. Then S3 is what? So determinant of the matrix, that is also we got 36. Therefore, by substituting, so the equation will get the lambda cube minus 11 lambda square plus 36 lambda minus 36 equal to 0. This is 11 is S1, S2 is the 36, S3. Now this is the required characteristic equation. Then next what we have to do is find the roots of this equation. But we know in the real number system, any nth degree equation has n roots. Therefore, it is the third degree equation. It has 3 roots. Then how to compute the roots of the third degree equation? So if you have calculator, in that calculator you can keep the equation mode, and just in calculator, if you have this type of expression, we have ax square, ax cube, bx square, cx plus d. Those who are using the calculator, in that go to the equation mode. So once you press the equation, this equation will be displayed. So after that, you have to choose this a, whatever we have, a is equal to 1, here b is equal to minus 11, and c is equal to 36, and d is equal to minus 36. If you press this ABC value, substitute ABC value, that calculator will give the roots of the equation. This is the one of the method. Or if you do not have the calculator, then how to proceed? So whenever if the third degree equation is given, if second degree equation, we are familiar with the factorizing into the second degree equation into simple factors. But whenever if you have the third degree equation, first you have to find one root by inspection method. What is called inspection method? By trial and error, you have to substitute value starting with 1, minus 1, 2, minus 2. Let us see, we'll check with you. So put lambda is equal to 1. So what happens? If lambda is equal to 1, this lambda cube will become 1. This is minus 11. 36 minus 36. It is not satisfied, it will not get 0. So it is therefore lambda is equal to minus 1. So whenever if you satisfy the equation, if you get 0 means that is a root. So therefore by inspection, it is not a root. Now we'll move to the lambda is equal to minus 1. If you put lambda is equal to minus 1, so minus 1 whole cube will become minus 1. So minus 1 whole square is the plus, will get minus 11. Then this is the minus 36. Then 36. It is also, you won't get 0. Therefore, it is also not a root. So lambda is equal to 1 is a not a root. Then lambda is equal to minus 1 is also not a root. Then we'll move to the next, lambda is equal to 2. If lambda is equal to 2, then 2 cube will become 8. Then 2 square is equal to 4. 4 times 11 minus 44. Then 36 times 2, 72 minus 36. Now we'll get 0. Now look at this one. 80 plus 80 minus 80, you will get 0. Therefore, lambda is equal to 2 by inspection. Lambda is equal to 2 is a root. So by inspection, we got a root. So once you get the one root by synthetic division, the third degree you can reduce this to second degree equation. So what is the procedure for that one? Now is lambda is equal to, is already we have the root. Now write the coefficients of this equation starting with highest to the lowest. You can write it. So what is the highest degree this lambda q? What is the coefficient? 1. Then lambda square coefficient is the minus 11. Then next 36. Then minus 36. Here put 0 and add this one. You have to start the process. Now multiply this 2 and write it here. 2 1 is 2. So this you will get the minus 9. So 2 times of minus 9 is the minus 18. This is the plus 18. This is the 36. If you get 0 means the process correct. So what this represent this, what are the left numbers? These represent the coefficients of the second degree equation. Already lambda is equal to 2 is a root, means lambda minus 2 is a factor. Now is a lambda square minus 9 lambda plus 18. So now it is a second degree equation. We are familiar to how to factor the second degree. Here choose two numbers in such a way that the sum is the minus 9, the product is 18. So the numbers are what? 3 and 6. Therefore, lambda minus 2, lambda minus 3, lambda minus 6. Therefore, lambda is equal to 2, 3, 6. Therefore, lambda is equal to 2, 3, 6. The roots of this characteristic equation are nothing but the eigenvalues of the matrix. Then how to check these eigenvalues are correct or not? So for that we have to use the properties. So we have two important properties for verification of the whether the obtained eigenvalues are correct or not. What are the properties of that one? The sum is equal to the, now look at this. What is the property that sum? What is the sum of eigenvalue? 2 plus 3 plus 6 is equal to trace of matrix or R. What is the trace of matrix? Is equal to also is 11. So the first property is satisfied. The sum of eigenvalues is equal to trace of. What is the product of eigenvalues? 36. That is equal to determinant of matrix. Therefore, satisfying these two properties, the sum is equal to the trace of the matrix, the product is equal to determinant of matrix. Therefore, whatever the eigenvalues we got, they are the correct. So next we will move to the, once we know the eigenvalues of the matrix A, by using the properties of eigenvalues, we can compute the eigenvalues of the following matrices. The first one, eigenvalues of A is lambda, that is equal to lambda. So this what we got eigenvalues of A, 2, 3, 6. The next one is the second question, eigenvalues of A transpose. Eigenvalues of A transpose. We know the first property. If lambda is an eigenvalue of A, the same lambda is also an eigenvalue of transpose. Therefore, eigenvalues of A transpose also the same eigenvalue. Therefore, the answer is 2, 3, 6. Okay. The next one, the third one is eigenvalues of A inverse. But we know if lambda is an eigenvalue of A, then lambda inverse is an eigenvalue of A inverse. So this is lambda inverse. So once we have the lambda, just take it the reciprocal. The reciprocal will get the eigenvalues of A inverse. So means So 1 by 2, 1 by 3, 1 by 6. So 1 by 2, 1 by 3, 1 by 6 are eigenvalues of A inverse. The next fourth one, eigenvalues of 4A inverse. So we know eigenvalues of, if lambda is an eigenvalue of A, then k lambda is eigenvalue of Ka. So therefore, the eigenvalue of this one is 4A inverse. So 4 lambda power minus 1 or 4 by lambda. So just you can multiply with 4 for lambda inverse, will get 4 by 2, 4 by 3 and 4 by 6. That is 2, 4 by 3 and 2 by 3 are eigenvalues of 4A inverse. We know already what are the eigenvalues of lambda inverse? 1 by 2, 1 by 3, 1 by 6. So therefore, if you know the eigenvalues of matrix, then how you will get the Ka? Multiplying the each eigenvalue by 4 will get the eigenvalue of 4A inverse. So multiplying with 4, this is 4 by 2, this is the 4 by 3, this is the 4 by 6, this is 2 jar, this is the 4 by 3, 2 jar, and 2 3 jar, you will get this one. The next one, fifth one, eigenvalues of A square. So we know if lambda is an eigenvalue of A, then lambda power k is an eigenvalue of A power k. Therefore, what is the eigenvalue of A square? Lambda square will become the eigenvalue of A square. So therefore, we have lambda by squaring, we will get the eigenvalue of A square. 2 square, 3 square, 6 square. So that is 4, 9, 36 are eigenvalues of A square. The sixth one, eigenvalues of A square minus 2A plus I. Then what is the eigenvalues of A square? Is a lambda square. What is the eigenvalue of, how you will get eigenvalues of A square? So lambda power k is an eigenvalue of A power k. So by using that property, lambda square is an eigenvalue of A square. Then how to get this eigenvalue of 2A? If you know the lambda is an eigenvalue of A, then k lambda is an eigenvalue of Ka. By using this property, 2 lambda is an eigenvalue of 2A. Then eigenvalues of identity matrix is always 1, if you remember this. Okay. So by substituting in this lambda value, we'll get 1. Put lambda is equal to 2, then what will become this one? 2 square, 2 times plus 1. So we'll get 4 minus 4 plus 1 is equal to 4. Then lambda is equal to 3 if you substitute. This is the first eigen. So 1 is the eigenvalue of A square minus 2A plus I. So next how we'll get by substituting 3 in this equation? 3 square, 2 into 3 plus 1. 3 square is 9 minus 6 plus 1. So this 9 plus 1 is the 10. 10 minus 6 is the 4. So next lambda is equal to 6 if you substitute in this equation. 6 square minus 2 times 6 plus 1. 36 minus 12 plus 1. 36 minus 12. Now this will get the 25. Therefore 1, 4, 25. So 1, 4, 25 are eigenvalues of the matrix A square minus 2A plus I. The next last one is eigenvalues of A cube 2I. We know what is the eigenvalue of A cube is lambda cube. Because of, if you know, if lambda is an eigenvalue of A, then lambda cube is an eigenvalue of A cube. What is the eigenvalue of 2i. We know eigenvalue of I, you have to write 1. So it will become 2. So the lambda cube plus 2 is an eigenvalue of the matrix A cube plus 2i. So by substituting lambda is equal to 2 in this equation, you will get the first eigenvalue of this A cube plus 2i matrix. Then substitute the 2 cube plus 2. 2 cube is the 8 plus 2 is the 10. Then 3, if you substitute 3 cube plus 2. 3 cube is 27. 27 plus 2 is the 29. Then 6, if lambda is equal to 6, if you substitute, if lambda is equal to 6, then 6 cube plus 2, this you will get 216 plus 2, 218. Therefore, 10, 29, 218 are eigenvalues of the matrix A cube plus 2i. So all these we obtain by using the properties of eigenvalues. Once we know the eigenvalues of A, so by using properties we can find out the eigenvalues of the A square, eigenvalues of A inverse, eigenvalues of the multiplication of a matrix. All these, whatever the matrices are there, are connected with the properties. So hope you understand these lectures. Thank you. I am ending the session.
Like, share and subscribe. Hit the bell icon for more updates.